I know this might sound crazy, but you may be implementing a Juniper device for the purposes of routing in your organization. Imagine that. In this nugget, we'll go ahead and take a look at routing on our Juniper devices. Lots of critical real-world production environment and certification information in this nugget. Now, you know it's not my style to do a lot of review in these nuggets because, quite frankly, that's a waste of your time. You can watch a nugget again should you need to review it. But I do want to make an exception to that here. Remember, there is this central separation that is so important to Juniper devices of the control plane versus the forwarding plane on your particular device. Like the spelling there? Remember, there's the routing table, and this is going to be fueled by things like your static routes, your directly connected routes, your routes learned from dynamic routing protocols like OSPF or BGP. And this routing table is going to place active routes into a forwarding table in the control plane. And you remember that forwarding table is copied down into the packet forwarding engine so that transit traffic can be moved very efficiently through your Juniper device. Now, as you might guess, there are multiple routing tables that can be implemented on the Juniper device. INET0 is hugely important. It's your IPv4 unicast routing table. INET1 is for v4 multicast. INET2 is for multicast BGP. INET3 MPLS. INET4 MSTP. This is the multicast source discovery protocol and is an aspect of multicast traffic. INET 6.0 is for your IPv6 unicast traffic, and MPLS 0 is for your MPLS next hops. Now, what gets placed in that forwarding table? Well, it turns out that the first rule that's consulted is what's called the longest match rule, and this refers to your subnet mask. So if there's a route for 10.0.0.0/8, and then there's a route for 10.10.10/0/24, for example, and you are sending traffic to someone in that subnet, sure enough, the longest match rule is going to hit, and you will utilize that /24-bit mask path to the destination. What happens if there are multiple sources, though, for these prefixes? Well, then the preference value of the particular route is going to kick in. The route source. Lower is better. It's like a golf score. So directly connected routes and local routes are going to have a value of 0, and we can't manipulate that. But everything else is going to have a higher value, and we can manipulate those route preferences. For instance, OSPF internal is 10, RIP is 100, BGP is 170. So these are the values, the believability scores of these particular routing protocols. If for whatever reason, and this is crazy talk, I know, but you wanted RIP to be more believable and preferred over OSPF, you could do this by manipulating the preference value of RIP and making it below 10, the value for OSPF internal prefixes. Now, it's simple to view your routing table on the Juniper device. You're going to be in operational mode and you'll say show route, or you could be in configuration mode and do a run show route. And notice you're going to see what table it is you're viewing, some summary information. Notice the asterisk for active routes, and notice that we get a look at the preference value as well as which particular direction we will be routing for that particular prefix. In the event that you have multiple different ways to get to a particular prefix, they will all be listed here in the routing table, and by default, the routing table will take a random approach to the assignment. So multiple equal cost paths, it'll randomly pick one to utilize. This approach provides load distribution among the paths while maintaining packet ordering per destination. You could go in and enable per flow load balancing over equal cost paths through a routing policy, and we'll be discussing routing policies together in this particular course shortly. And another cool capability that we have on the Juniper device is to actually create multiple routing instances. This is how we can have one router appear to be many different routers on the network. This is virtual routing, for instance. So here, if I do a show route instance, we'll see that on this particular device, we're dealing with the master instance of the routing table for iNet 0. If we were to go into configuration mode, we could do edit routing instances. I could name it my test, and we could set the instance type to one of these possibilities. For instance, a virtual routing and forwarding instance, or a layer 2 VPN routing instance. So notice we are not limited to single routing tables on our devices, and we can engage in plenty of virtual routing possibilities on the Juniper devices. Something else that we need to be aware of is what is often called the bit bucket, and that is how we can have the device throw traffic away. Notice this reject keyword. When you have the reject keyword associated with a route, and you can literally do this statically if you like, the reject keyword is going to have this particular device drop traffic for that destination and send an ICMP message to the source, letting the source know, look, that network is unreachable. The alternate way you could do this is with the discard keyword. With the discard keyword, we're going to drop the traffic, but no ICMP messaging is sent back to the source. So some of these surrounding principles might take you a little bit of getting used to on the Juniper device. I've got plenty of flashcards, as you might guess, to help you along in that process. But the great news is the configuration of routing is pretty straightforward. So notice I would go into configure, for example, and for static routing, we would say edit our routing options. And to create a static route, we could simply say set static. We would say route. For a default static route, we would specify the all zeros /0, and then you can specify a next hop for that particular static route. So I'll say the next hop is 10.10.10.2 here, for example. Notice additional options do exist. For instance, you could say resolve. This would allow the resolution of an indirectly connected next hop. Certainly it is recommended that you have a dynamic routing protocol available in order to resolve that next hop. Another particular keyword I want you to be familiar with is no re-advertise. So what this would mean would be we don't want this static route redistributed or advertised into a particular routing protocol. So we could prevent that with no re-advertise. A time that you would want to do that would be in a situation where you maybe are using a static default route for management traffic purposes, but you want to keep this out of band from data traffic. Now I think it's time for us to go ahead and engage in a dynamic routing configuration. Probably overdue in a nugget entitled routing, right? So let's go ahead and do this. So here we are on Juniper device, and let's go in. Let me just show you what I set up behind the scenes real quickly. So if I do show interface terse, you will see that on this particular interface, we have the Gigabit Ethernet 000 Unit 0 interface set up with an IP address. If you want a quick review on how to set up an IP address, we'll do that together in a second. I have a device connected to this device utilizing the gigabit Ethernet 000, and I have the 10.10.10.2 address configured. We want to begin dynamic routing between these devices, of course, by ensuring they can communicate with each other. So let's ping that neighboring device. We'll do a count of 2 to keep it simple, and we see we do have layer 3 connectivity between these two devices. Great. Before we leave this device, let's do the OSPF configuration. I'll get into edit mode and I'll say edit protocol OSPF. Simple. Now in protocol OSPF configuration area of the hierarchy, we simply say set area 0 on interface gigabit Ethernet 0/0/0.0. How is that for simple? We'll go ahead and show to verify that we did this correctly. Great. That interface is in area 0. I love how they take the area and they resolve it to a 32-bit area identifier. That's great. So I'm going to say commit and quit over here on Juniper device. On the Juniper device 2, we're going to slide over there, set up some interface addressing to share between these devices, and then do our OSPF verification. So here we are on Juniper device 2, and what we're going to do here is, as I said, set up some additional addressing that we can share between these devices with the dynamic routing protocol. So I'll go into edit interfaces, and we're going to edit the loopback interface. It's unit 0. And here we'll go ahead and set family iNet, and we are interested in setting an address. We'll do 10.20.20.2/24 here, and then let's just do one more for fun. We'll do 3030. So this is additional address space on the virtual loopback interface that we can share between these devices. It's time for us to do our edit protocol OSPF on this device. We are going to set area 0 on the interface gigabit Ethernet 0/0/0.0, and we're also going to do this on, you guessed it, loopback 0.0. So we should be able to commit this configuration and quit it, and then we're going to slide back over to Juniper device 1, I guess we could consider it, and we are going to see if our OSPF is fully functional between these two devices. So here we are on our first of the 2 Juniper devices, and the verification should really be a 2-step. I guess if you wanted to cheat, you could go right to the routing table, couldn't you? But a really nice verification command you're going to want with OSPF is show OSPF neighbor. And this says, yeah, look, you have a full neighborship with the device at address 10.10.10.2. Excellent. So now if I do a show route protocol OSPF, we'll see our local routing table here, and we'll see that it is being populated with the address space that we would expect to see from the Juniper device 2 that we are now OSPF neighboring with. Notice our protocol designation here, our preference value here, and our next hop value and interface values, all what we would expect, including our metric. So a hugely important nugget here on the critical topic for us of routing, specifically routing in the wonderful world of Juniper. There was a lot of topics here, including basic routing operations and concepts, our routing table, our configuration and monitoring of static routing, and the configuration and monitoring of basic OSPF. I sure hope you found this nugget informative, and I'd like to thank you for viewing.